Welcome back to Coffee with Carl. Now we said we would talk about space-time and general relativity, but before we do so, I thought it would be interesting to look at this passage from a book by Smolin called The Trouble with Physics. First thing that's interesting about this book is that the title is printed upside down on the cover, which is already suggesting that there's something upside down about the way we look at reality. And in my experience, this is the first time in reading a book that popularizes science that someone actually says this. What's the wrong assumption that's preventing progress? Well, he identifies two. One of them is to do with quantum mechanics, which need not bother us now, but the other is to do with the nature of time. And this is what he says. More and more, I have the feeling that quantum theory and general relativity are both deeply wrong about the nature of time. It is not enough to combine them. There is a deeper problem, perhaps going back to the origin of physics. And then he talks a little bit about those origins in the 17th century and what Descartes and Galileo achieved. And what they did was basically represent space and time as a graph. And this is what Smolin has to say. Motion is frozen, and the whole history of constant motion and change is presented to us as something static and unchanging. If I had to guess, he says, because that's what he does for a living, this is the scene of the crime. That's a very useful way of putting it. There's a real problem. This book, incidentally, is pointing out that nothing new has been discovered in science for at least 30 years. It's almost as if it's come to a cul-de-sac. And that is the scene of the crime. Why is there no progress? And this is what he says. We have to find a way to unfreeze time, to represent time without turning it into space. And there's this one line that comes next. I have no idea how to do this. Why not? Because I can't conceive of a mathematics that doesn't represent a world as if it were frozen in eternity. It's terribly hard to represent time, and that's why there's a good chance that this representation is the missing piece. So there's the problem. It's what we were said at the very beginning. If you build a system on the principle of inertia, then whatever conclusions you may come to, ultimately in that system, inertia will be there at the end. And here, that notion of inertia is represented by space-time. And space-time commands and matter acts. So again, matter is inert. Well, normally when people try to explain space-time, they do so by talking about a rubber sheet. There's a dent on the sheet. That's where space-time is curved, and that's what gravity is. And so we get the impression that the description in Newton is finally turned into a mechanism in Einstein, except for one thing. And we're going to look at that later on, which is that the alliance of space and time was decided long before Einstein got to the general theory of relativity, and we'll see why in a moment. But here, Smolin actually puts his finger on the problem. It is the alliance of space and time. Now, I'm not the first person to be critical of science in this way. Plenty of physicists have said there's something wrong with our assumptions, and they get to this point when they talk about space-time. But what generally happens is they put another system into place. And here's the point. You don't need another system. In fact, that idea of a mechanism being put into place to describe, to explain something is really derived from the principle of inertia, because the solution to the problem is already in relativity. It's in special relativity, because it's space and time that have been allied in general relativity. But when you look at special theory, a completely different alliance is already suggested. And I would like to suggest this here as something to follow up later on. When anything is in motion, its time changes. That is to say, if you picture anything as a thing, you picture the time as a kind of wristwatch strapped to it. And that clock or that wristwatch slows down the faster it moves. But that's not the only thing that changes. The mass of the thing to which the wristwatch is strapped also changes. So here you have two changes of state occurring to the same thing at the same time in the same place. And there's the solution, which scientists cannot possibly consider for reasons we're going to come to later. It's simply this: the alliance should never have been space-time. It should have been mass-time. The difficulty with mass-time is manifold. In the first place, it suggests where space-time commands and matter acts, that component which is doing the commanding, which is time, is now allied to mass. So it's mass-time that is commanding and space that is acting. So that really is quite a novel and unknown solution to the problem that Smolin puts. And the reason it's unknown has already been given by Smolin. I can't work out how to find a solution because I'm fixed into statics, into mathematics, which presents a still. But now the dynamic component is in matter. We need an entirely different way of thinking about this. And perhaps this would be a good time to stop, to give you time to think about what can mass time probably do that space-time can't, especially with regard to the quantum gravity problem, which we may touch on later. So cheers.